Hello, my name's Martin Rebb. What I'd like to go through and explain with you today is where a hydraulic RE surge anticipating valve can easily replace the need for surge vessels. The valve itself is a globe type control valve that is looking at the main and determines when and where a surge happens and opens to relieve that surge to protect the main from any high pressure or low pressure negative surges. The valve itself is a 200mm in this example, and it's controlled by two hydraulic pilots. This pilot senses if there's a positive high pressure surge, and this pilot senses if there's a negative low pressure surge. What causes a surge in a pump system is normally a pump trip. If the pump trips, then the volume of water moving through the main itself remains constant for a few seconds, which means at the valve's location will go negative and actually drop to zero because the water's still moving up the trunk main. In that circumstances, the valve senses that extreme low pressure and immediately opens, anticipating the surge positive wave, i.e. the water coming back down the main. It being in an open position at that point ensures that the water's got somewhere to go. If it wasn't here and it wasn't open, that water just slams against the check valve, causing a transient surge. So as I said, this is the low pressure pilot, that's the high pressure pilot. You can see that the pump is currently running at 4 bar. When we get the pump trip, which we will simulate shortly, you will notice that the pressure gauge will suddenly drop to zero. The valve senses that, and you'll see water being discharged from these ports, which are half-inch ports to enable the valve to suddenly pop open, waiting for the positive surge to come back. Now, transient surges can move at about 1 kilometre per second, so that's how quickly the valve has to react and anticipate the positive surge coming back. When the valve's open, you will then see the pressure returning up from zero and increase up, and you'll see a very small transient happening as the valve's discharging and protecting the system. So if we can initiate a pump trip, which we're just about to do in a sec, so if we can focus in on the pressure gauge, you'll see if we can have the pressure gauge and the valve in the picture. You'll in a minute see it suddenly drop to zero because 900 meters cube per hour is currently moving down the main, and when we trip, that volume of water still carries on moving, which causes a negative pressure here. And our air valve will, which we'll show you in a minute, automatically opens at that point to make sure we don't get subatmospheric at this point as well. That's the valve opening up. That was only one pump trip. We want all pumps. There you go. The valve's opened up, it's sensing that. And you can see now by the pressure gauge, instead of a massive pressure surge, we have now got a very slow, smooth transient surge as the water's slopping backwards and forwards. But there was no high pressure, no sudden movement of pipework which damages and can rip joints apart, which you can see in the following documentary of what happened at this location when this valve wasn't installed and the pumps tripped. The whole pipework under us, including the thrust blocks, got ripped apart.